I remember 2 Voyager missions launched in 1977. Shortly after launch, they turned around, they got the Earth and the Moon in the same picture. I've just been fascinated with imaging from deep space missions ever since, and I've been very fortunate to be able to create some of those pictures.
Psyche is what's called an M-class asteroid in the main asteroid belt between Mars and Jupiter.
It's the 16th asteroid discovered back in the 19th century, and we think that maybe it's the remnants of a planetary core.
All of the missions I've worked on had some sort of an imaging device.
Isn't that the first question that everyone asks? What does it look like? And so I've been dreaming about this object now for over a decade, and by then it'll be 2 decades I've been dreaming about this object. And then to see what it really looks like, what's more exciting than that?
For Psyche, we know it's going to be a relatively dark object. So we have to have an instrument that can see in that sensitivity with a dark surface and still be able to resolve the features that we're looking at.
The cameras on Psyche, we call them the Psyche multispectral imagers. They're a pair of identical cameras. They're a pair for redundancy, just in case we have a problem with one, we've got the other one.
And with stereo, we can build what's called a digital terrain model, the surface of Psyche, which we're very interested in knowing at a high resolution. Using the different filters, we actually can infer geochemistry of the surface. We can also associate it with the gamma ray and neutron spectrometer data set to sort of really drill down into the composition of the asteroid.
We'll also take pictures farther out into the infrared where these sensors are still sensitive and where we can get a little bit more information about the kinds of rocks and minerals on the surface. One of the other functions besides science for the cameras is that they are our navigation cameras as well. This technique that was invented back in the 70s called optical navigation. Take pictures of stars and star fields, kind of like looking at a sextant on a ship hundreds of years ago. The same process is used in modern space missions as well.
The instrument's actually being built by a company called Malin Space Science Systems. They built the LRO camera, they built Mastcam, they built Mastcam Z, they've built numerous other cameras that have flown to Mars. And they do the final fabrication and quality control before then delivering that instrument to JPL.
No deep space camera system like this has ever been built. However, the components that go into the cameras all have a lot of experience in space, a lot of what NASA calls heritage.
When we get to Psyche, we'll go into orbit. The imager will primarily work during orbits A and B to get the images, to characterize the surface features, to make the topographic map, and to get the color images, which will hint at the composition.
Standard plan is that we're pointed straight down and we're snapping pictures as the asteroid rotates underneath them.
Usually the most important image that everybody gets excited is that first image that we acquire that you get back.
We are super committed on the Psyche project from PI, Lindy Elkins-Tanton, all the way down to sharing this experience with the public. I think the only thing we know, and that's based on NASA's 50, 60-year experience now, is that it's not going to look like what we think it's going to look like. And it's going to be really interesting, whatever we find.